Okay, so let's talk about applications. The way I see it, the applications are endless. Anything that you can use a compression engine to do, this engine will do. Anything that you can do with a Stirling engine, this engine can do. Anything that you do or can do with any type of thermal or compression engine of any sort, you can do with this engine. I've actually even designed a way to use jet pulse technology to use suction to drive the turbine. And yes, it does suction. So the applications are endless: automotive, industrial, residential. Now here's my idea for residential. You take one of these, which is silent once it's in a closed loop system, by the way, and it's very safe. It only gets up to 35 to 50,000 RPMs for the really small ones. For the bigger ones, they can range from 7,500 RPMs to 2,200 RPMs. Now, one of the other aspects is obviously waste heat. If you have a heat source and you have a working fluid and a thermal capture unit, which I've designed, and a thermal capture unit will capture the thermal essence of the energy that you're trying to use from the waste heat, and then transmit that through a very amazing fluid that I found. It's relatively expensive, but for our use, that doesn't matter, and here's why. It's a very small closed loop. It's not a big closed loop like a bladed turbine would have to be. It's a very small closed loop because the whole system runs on pressure, not volume. And then you take that heat source and that thermal capture unit and you drive one of my turbines with a generator on it. It runs fantastic. I've already built one. The next thing would be automotive. Let's say you wanted to take the 5,000 BTUs per minute from the automotive engine, turn that into waste heat, which the radiator expends out into the atmosphere, and we just tie into one of like the hot pipe on the top, and capture that, replacing a section of it with a tubular thermal capture unit, and it heats up the fluid and drives the turbine, replenishing the battery. You can literally get rid of your alternator. Literally. Now, there are other applications out there. Diesel, automotive. I've actually designed a turbine in a turbine. So basically, it uses my turbine to drive a bladed turbine. Do you see where I'm going with this? It drives a bladed turbine from the pressure and turns it into volumetric air, cold volumetric air. The air going through the turbine is recycled as cold air intake. In fact, that's what we call it. We call it a CAT, cold air intake. That air will turbocharge any vehicle with instant response time. All you have to have is a way to control it. And obviously, you can use electronics to tell it you're going to deliver air to this turbine at this sequence of events, in this sequence of events, like when the car's taking off, when the car reaches 2,000 RPMs. It's endless as to what you can do with this device. One of the other things that I've developed so far that I haven't told anybody about is a home thermal capture unit. That means you can take propane as your thermal source, just like a water heater, and back. I built it into a water heater so that you take the heat from a water heater and because it runs at low temperature. The fluid I'm talking about, by the way, is called 245 FA. Look it up. It boils at room temperature, 69.9 degrees Fahrenheit. It boils. This stuff is so fantastic. You can take a bottle of it, put it in your hands, wrap your hands around it, and watch it start boiling. It is phenomenal. Now, if anybody else can come up with some more applications, because I've got endless applications, but I'm going after the waste heat industry, AI, and data centers. They have tons of waste heat. I can get them 35 to 40% back on their usage from the waste heat that they generate from the systems. So that means that I can literally almost at 100% system efficiency, literally at almost 100%, get them back 30 to 40% of the functioning waste heat that's in the system. I'm going to take a break.